welcome to another episode of Hidden Gems. Back with us today is David, who I'm very excited for him to talk about the most recent research paper that he's done on the modular blockchain thesis. How are you doing today, David?
I'm doing great. Thanks for having me on again.
Ooh. So before we dive into the actual discussion, two questions I had for you.
Mhm.
How do you think the modular blockchain thesis proposes to enhance blockchain infrastructure? And just to give our listeners a better idea of what we'll be going over today, could you just
Mhm.
share just some key topics on your research paper that you'll be going over?
Yeah, for sure. So we all know that Ethereum's layer one has some scalability issues. And to solve it, blockchain researchers have kind of turned to layer two solutions, such as rollups to scale Ethereum. But the true breakthrough that layer twos actually gave us is their next evolution, which is modular blockchains. And what the modular blockchain thesis is by modularizing the blockchain, which kind of means splitting up the processes that are traditionally all handled on Ethereum's layer one among specialized chains. We have the potential to achieve 20 to 50x improvements in transactions per second on Ethereum. So super excited to be here today again to kind of go over how modular blockchains work, what sets them apart from their monolithic counterparts, and explore the different Ethereum modular layer 2 stacks, including rollups like I mentioned earlier, such as Optimism, and also some modular rollups like Mantle.
Okay, perfect. So before we dive into that again, let's first establish the basics of the blockchain infrastructure. Can you
Mhm.
explain the different layers that make up a regular blockchain system?
Yeah, so at its core, every blockchain carries out the same set of tasks, and this can be categorized into four distinct processes or layers. So first we have execution. This layer serves as the initial processing hub for transactions and also blockchain state changes. It's also the primary interface where users like me and you interact with the blockchain, where we can sign transactions, deploy smart contracts, transfer assets, and more. The second layer we have is the settlement layer. So blockchains offer finality, and that's basically the guarantee that these completed transactions are immutable and also irreversible within the blockchain's history. So everyone talks about immutability, and that's basically what finality is, right? And achieving this, though, requires validating transactions, verifying these proofs, and also resolving disputes. So this is all encompassed within the settlement layer. The third layer we have is the consensus layer, and this basically facilitates nodes in reaching a collective agreement on these verified and accurate transactions. And the consensus layer also plays kind of a big role in ensuring the global state of the blockchain. So it determines transaction order and adds new blocks to the blockchain. And finally, we have data availability. Everyone's been talking about data availability these days, but this layer basically stores and publishes the transaction data necessary to validate the state transitions. So block producers will hold and make this data accessible upon request, and also ensure that malicious actors cannot kind of withhold transaction data during potential attacks. So we can envision these four different layers or processes: execution, settlement, consensus, and data availability as individual layers compromising the entire blockchain.
Okay, interesting. So I know that monolithic blockchains have been the norm up until recently, but it would be great if you could actually shed some light on what a monolithic blockchain is, just for the listeners who don't know or who have never heard it.
Yeah. So traditionally, blockchains have had a monolithic architecture, and a monolithic blockchain is basically a single chain that executes transactions, provides settlement, offers consensus, and guarantees data availability. So all four processes we mentioned earlier, they handle all of these at the same network layer and the same network level. So a good analogy is, imagine you're at a restaurant and you saw the owner take on the roles of chef, a server, bartender, and cashier simultaneously, right? So this restaurant will no doubt be very busy. It will also have a lot of high costs and limited capacity. And this is basically what monolithic blockchains are like. And some examples I'm sure we all know are Bitcoin, the first version of Ethereum, and also Solana. And since the same layer is asked to do all these four processes simultaneously, this leads to the infamous monolithic blockchain scalability trilemma, which kind of describes the challenging trade-off between decentralization, and this is the distribution of power amongst network participants, usually measured in terms of nodes or validators in the network, scalability, which is the ability to handle large volume transactions, which is TPS, and security, the trustworthiness of the network, which is determined by the resistance to attacks. So as we can see on the screen here, the monolithic blockchain scalability trilemma states that with current technologies, it's only possible to prioritize two of these free properties at the same time. So to enhance one component, sacrifices must be made in one or more of the others. So for instance, let's give an example here. Ethereum's layer 1 prioritizes security and decentralization, which leads to high gas fees and slow transactions during peak times, which is option B here. Alternatives like Solana, for example, they prioritize throughput, but at the same time, they trade off some level of security and decentralization, often relying on fewer nodes, which is option A here. However, I think it's really important to emphasize that sacrificing decentralization to boost throughput does not truly constitute scaling. And, as our industry evolves, yes, we do want blockchains to be more scalable, but a decentralized and secure system remains the highest priority still.
Oh, amazing. So the limitations of monolithic blockchains are definitely becoming more and more evident. But how do you think modular blockchains address these challenges?
Yeah, so typically a modular blockchain focuses on one process and delegates at least one or the other four processes, which is execution, settlement, consensus, and data availability to external chains. So in the context of our restaurant analogy earlier again, now imagine you go to this restaurant and the owner has hired individual professionals for each of the positions. So all of a sudden, this restaurant can cater to more customers, it's more affordable, and it's also less busy. So this is precisely the thesis of modular blockchains, that a singular blockchain does not need to bear the burden of handling every single process for the four layers. So by separating the execution, settlement, consensus, and data availability layers into separate layers, four different layers here, individual blockchains can concentrate on specializing on just one of these processes or one or two of them. So it's important to note here that these modular blockchains are very different from networks of chains, where each chain handles all processes, like here on the left, for example, Cosmos zones, right? Where they're like a network of blockchains. They're like app chains. Whereas a modular blockchain represents like one layer on the right, right? Within a broader modular stack of chains, which make up all four layers. So they work together and you can kind of plug and play with them.
Okay, so it seems that a modular architecture seems to be very promising. And I love the analogy of the restaurant and the chef. It's easy to picture that. Would you be able to outline some of the notable benefits of adopting a modular blockchain design?
Yeah, for sure. So there are three main benefits to adopting a modular blockchain design here. And the first one is scalability. So the beauty of a modular blockchain is that it can distribute tasks across different layers. So for example, one layer may handle execution, while another manages settlement and consensus, and a third one takes charge of data availability, for example, right? So this modular approach will pave the way for more scalability because you're not handling all four different processes and tasks within one layer, where it often gets overloaded or clogged. The second benefit is launching new chains. So previously, launching a new chain is very difficult because you need to build up security properties for a new blockchain. So for example, a proof of work blockchain needs to attract miners to prevent a few parties from controlling the network's hash rate, or a proof of stake blockchain needs to establish a wide distribution of tokens to avoid centralization risks. But with modular chains, developers can now focus on the minimum component, such as just the execution layer, while plugging into specialized layers that handle security or consensus, right? So this eliminates the need to build every single part of the stack from scratch, where you can just focus on execution, for example. So we're seeing this with rollups and lots of modular rollups as well. And finally, the last benefit is flexibility. So this is, I would say, the most ultimate advantage of modular blockchains. And this is something that monolithic chains just can't offer. Modular blockchains are basically, like I mentioned, pluggable modules. So you can plug them here, plug them there. So for example, execution layers or data availability layers can be easily swapped depending on the use case, right? So this lets developers make changes to the blockchain really quickly and easily without a full-scale upgrade. And later when we talk about Mantle, I'll provide some more detail regarding the flexibility of modular blockchains.
Perfect. Looking forward to going over that. So I understand that Ethereum's modular L2 stack is an exciting development. Would you be able to explain the concepts of Monolith, Rollup, and Modular Rollup?
Yeah, absolutely. So in its early days, Ethereum, like many other first-generation blockchains, was built with a monolithic architecture. But now the Ethereum network, as we all know, is undergoing a shift towards a modular layer 2 tech stack. So let's take a look at the different Ethereum centric modular stacks that have emerged on the screen right here. So first we have the monolith, and this is the Ethereum mainnet or layer 1 in its original form. So this operates as a monolithic blockchain. So this monolithic architecture grants maximum security, but it comes with the trade-off of high costs and limited scalability. So this is why the Ethereum mainnet's transaction speeds have been pretty slow, averaging only 15 to 20 transactions per second. So then we have the rollup. So rollups are basically the original breakthrough in modular blockchains. They offer a separate layer for execution to scale the Ethereum mainnet, but it also relies on the Ethereum mainnet for everything else. So it's an execution layer, but it relies on Ethereum for settlement, consensus, and data availability. What a rollup does is it abstracts the execution to sequencers, and sequencers are basically these powerful computers that can bundle and execute multiple transactions before posting the compressed data back to the Ethereum mainnet for verification. And by shifting this off-chain with respect to Ethereum's mainnet, these rollups can achieve a remarkable 20 to 50x increases in transactions per second. So this was the original modular blockchain. And then we have the modular rollup. So these are newer modular rollups that move the data availability layer off Ethereum 2. They're essentially rollups with off-chain data availability. So it's cool to kind of note that up until recently, Ethereum was actually the only data availability solution for rollups. And this kind of sucked because it became the largest cost bucket for a lot of rollups. So 70% of rollups expenses come from storing transaction data on Ethereum, actually. And this cost is also a variable cost, and it increases with usage, making it a big problem as more and more users come on board. So the good thing now is we have new modular solutions in the form of data availability layers to reduce these transaction data submission costs. So some leading examples of data availability layers are like EigenDA, Celestia, and Avail, which I'm sure everyone's heard of recently. They've been the talk of the town, but they offer these modular capabilities to modular rollups.
Okay, so I could see why rollups have been popular in terms of a scaling solution for Ethereum. Another question I have, because I love the data charts that you've been providing, they're so visually inspiring in the previous built on blockchain segments that we've done. Would you be able to provide some examples of rollups and share any interesting data points that highlight their impact?
Yeah, for sure. So some notable examples of rollups are the Arbitrum and Optimism chains. They're basically the leading optimistic rollups that take execution off Ethereum's layer 1 and also publish these state roots and rollup data back to Ethereum's layer 1. So Arbitrum and Optimism, they allow for faster block times and bigger blocks without compromising decentralization or security, because as we mentioned earlier, Ethereum serves as the base layer or layer 1 for these layer 2 chains, which is Arbitrum or Optimism. So an interesting data point here is that actually Arbitrum and Optimism's total transactions already surpasses Ethereum's total transactions, as you can see in the chart here. So this basically means that users are using these rollups way more than Ethereum mainnet for everyday transactions and transfers because it's cheaper, faster, more scalable. And this trend proves the remarkable modularization of Ethereum and that it's actually working.
Oh, amazing. So I would love to talk more about a specific modular rollup that you mentioned earlier, Mantle. How does Mantle leverage the modular blockchain design, and what benefits does it offer in the context of the modular rollup architecture?
So as I spoke about earlier, existing rollups on Ethereum, they face a lot of high costs due to their reliance on Ethereum for data availability. So 70% of a rollup's costs is due to posting this data on Ethereum. So Mantle is basically a solution to this. They're the first ever modular rollup that uses optimistic rollups for the execution layer, but they also delegate data availability to a separate data availability layer called Mantle DA. So Mantle DA is a data availability layer that orders and provides proof of data, but without executing transactions. So there's a execution layer, which is Mantle rollup, and then there's the Mantle DA, which is a data availability layer. And this Mantle DA is a result of the close collaboration between Mantle and EigenLayer. So these two teams work together on this, and they built Mantle DA using modified EigenDA technology. So this is basically the state of the art as best as it gets for EigenDA's mainnet release. So essentially, to recap, since it's kind of complicated, essentially Mantle posts rollup data to a separate data availability layer called Mantle DA, but it still relies on Ethereum for settlement and consensus. So it's the execution layer and the data availability layer, but it relies on Ethereum for settlement and consensus. And this modular approach basically allows Mantle to benefit from the security of Ethereum while bypassing the need to post complete rollup data to Ethereum's layer 1, which significantly reduces the transaction costs and improves the transaction speeds. And this is why there's a lot of diverse use cases that require high throughput on Mantle's network. So we see a lot of DeFi, a lot of gaming, a lot of social applications, all due to the benefits of Mantle DA. So another benefit of Mantle's modular tech stack lies in its flexibility. So I brought up flexibility earlier. This is a really good example to kind of paint a picture of what it is. So for example, as I mentioned, Mantle DA is currently just a temporary solution and it's built with Eigen DA. So when Eigen DA launches a mainnet, Mantle will be able to swap out its current Mantle DA module in favor of Eigen DA. So the data availability layer can easily change. And also Mantle's consensus mechanism can also easily be replaced with ZK EVMs when they're production ready. So they're currently using Optimistic rollups, but they can use ZK technology if they want. It's easily pluggable and switchable. So this kind of showcases the power of modular blockchains, right? Where you can have a highly performant chain like Mantle that remains adaptable to evolving technologies. So you never have to stick with one option. You don't have to rebuild the whole thing from scratch. You can easily plug modules that are the latest technology to improve your stack without like a full-blown operation.
Okay, amazing. Thanks for listing out all those benefits. So I know Covalent's partnership with Mantle has been significant since day one. Would you be able to share insights into how Mantle's ecosystem has evolved and grown since the partnership began?
Mm-hmm. So Covalent has partnered with Mantle right when they launched their testnet. So since day one, we've been supporting their ecosystem, and Mantle's 6-month-long testnet was very, very successful. So it saw over 60 million transactions processed, more than 1 million unique wallets, and over 50K developers onboarded. And this is all at an incredibly low gas cost because of Mantle DA. So they've been very impressive on the testnet stage, and recently we supported their launch on mainnet. So the testnet kind of set a good stage for the mainnet. And, as we can see in the two charts here, Mantle mainnet has already gained 2,000 daily active addresses, and they've had more than 35,000 daily transactions just a week's time. And in case you guys didn't know, Mantle also has a treasury of 3.6 billion in hard assets, which is backed by Bybit and also BitDAO, making it one of the most capitalized layer 2 solutions on the market right now. So it's currently offering developers like you and teams grants that range from 10,000 to 150,000 to build a Mantle. So make sure you go check out their website and build on the network.
Thank you so much for sharing those insights. So last question, looking into the future, how do you envision the development of Ethereum and modular blockchains, and what potential trends and advancements do you predict in the next year?
Mm-hmm. So I feel like in the past decade, we've been stuck in this cycle of creating new layer 1 blockchains because of Ethereum's high costs and limitations. But in hindsight, now we know that the high fees on Ethereum are not a bug, but rather a feature of decentralization. So I think today we really live in a world where modular layer 2 solutions are the norm for mass adoption, and competition is also heating up at the data availability layer. So I predict that the barriers of entry for new rollups will significantly reduce. And also in the next year, I think we can anticipate a boom in application-specific rollups and also general purpose rollups on the OP or ZK stacks. And this is all because of cheap data availability and also the power of modular blockchains. So this is what I think the future will look like, and it's certainly going to be very, very exciting.
That's awesome. So I wanted to thank you so much again for coming on to this episode. Pretty excited to have you for future built on blockchain episodes as well. If you guys haven't had a chance to read his research paper, I will provide it in the description below. And if you haven't taken a look at the other previous videos that David has done on ZK EVMs or just the comparison with Optimism and Arbitrum, the playlist is right here. Would you want to share any closing thoughts before we close off the podcast?
Yeah, thanks for always having me on, Jackie. You're killing it, doing a great job as well. And developers, if you're looking to build a Mantle, you can kind of sign up for a free API right here. You should see a QR code pop up on the screen. Our API is completely free product, so you can go ahead, use it, and deploy your dApps on the Mantle network.
Right, perfect. Thanks again, and we'll see you on the next episode.
Thank you.
Bye.